Hey, geometry people, it's another geometry video. Well, kind of we're doing like trig videos these days, but it's related to geometry. Trig and geometry are quite related. So here are a couple of problems for you. It'd be worth it to take a little time and see if you can solve them on your own before I talk about them. So if you want to do that, pause the video. I'll be back in just a second to solve it with you. All right, so if we have a right triangle and we know one angle of the right triangle and we know one side, we can always solve for another side because we have the magic of trigonometry. And trigonometry is just sort of a predictable set of steps, predictable ratios that we can use to find side lengths in right triangles. So the first step is to label your sides. And so that starts with recognizing what your theta is. This is 57 degrees in this case, and opposite theta is the opposite side, and so we label it as such. Across from the 90-degree angle is your hypotenuse, so we're going to label that. And then the other side is the adjacent. Now we have to decide what we have and what we want. We have the hypotenuse, we want the adjacent, and so that's going to help us pick a trig ratio. There are three: the sine, the cosine, and the tangent, and they're remembered by thinking so, so on. Now, since we have the A and the H in play, we're going to choose the cosine. These two aren't useful because we don't know or don't want anything with the opposite. So now we're going to use that cos to help us build an equation. The cosine of the angle is the adjacent over the hypotenuse. And we literally just say it and write the pieces in. So now we can pick up a calculator or look it up in a trig table, and we can make sure our calculator is on degree mode, and then calculate the cosine of 57. For my calculator, I just put in 57 and then press cos, and what I get is 0.544 and lots of other numbers, so let's say 0.55. I round to two decimal places, that's my preference, and then that equals x over 10. To clear that 10 out of the denominator, just multiply both sides by it. And you have this cancellation. Now 10 times 0.55. Oh my goodness, something happened weird. Well, anyway, it's 5.5. Just move that decimal point over one place, equals x. And you are done. And so we know that that side, that adjacent side, is 5.5 units long. That's how trig works. It's not terribly tricky. Some of trig is, but right triangle trig is actually fairly accessible. It's a series of steps, and if you just follow them every time, you can get these problems done. Now, problem 2, can you find the value of theta in this triangle? If so, do it. If not, what do you need? Well, this is interesting because this is a right triangle. We know two side lengths. We could easily get that side length by throwing the 22 and the 57 into the right places in the Pythagorean theorem, but we don't have anything yet that helps us solve for an angle when you know two sides. Well, not yet anyway. All right, update that notebook, please, and then come on back. Okay. So the essential question, how can you find angle measures when you know side length? The topic is inverse trigonometric functions. This is cool. So there is such a strong relationship between the angles of right triangles and the sides of right triangles that we can even do trig backwards, essentially, and use what's called trig inverse functions to figure out angle measures if you know side length. That's what we are up to today. So far, we've used trigonometry to find the length of the side of a right triangle when we know the length of one side and the measure of one angle. For example, we can figure out the length of r by recognizing that 41 is the angle we're working with, or theta, and that side is the opposite. Across from the 90 is the hypotenuse, and the other side is the adjacent. It looks like we have the adjacent, and we want the hypotenuse. And so we're going to choose between sine, cosine, and tangent by remembering so, ca, toa. Well, we have the A and we want the H, and so again, we're using the cosine. Seems like we're using that a bunch lately. And then we're going to use that to set up our equation. The cosine of the angle is the adjacent over the hypotenuse. And now we have the variable in the bottom, but that's okay. I mean, it happens sometimes. Now we're going to figure out a numerical decimal, a decimal approximation for the cos of 41. 41 cos is how you put it into my calculator, and I get like 0.75 equals 15 over r. Well, to clear that r, I'm going to multiply both sides by r, which cancels them, and I have 0.75 r equals 15. Now I'm going to divide both sides by 0.75, and I can figure out that r, the hypotenuse, is 15 divided by 0.75, and it's 20 meters. Done. So we can do that. If we know one side length and one angle measure in a right triangle, we can find any other side length. But we can also use trigonometry to find the measure of an angle if you know the length of any two sides. We can turn side lengths into angle measures. There's a couple of ways to do this. First of all, we're going to talk about calculators. So the labeling of the correct buttons that you're going to use on the calculator is going to depend on the type of calculator you have. See the sin, cos, and tan buttons? You know what you're doing with those now. Now you know what they're for. Now look right above those buttons. You're going to see a possibility of a couple of things. On my calculator, I get like sin to the -1, cos to the -1, and tan to the -1. That's what it says on my calculator above those. Kind of tiny above those buttons. Your calculator may say a cos, a sin, or a tan, and it might even say cos H, sin H, and tan H. All of these things are the same. It all just depends on how your calculator manufacturer decided to express these buttons. These buttons calculate inverse trig ratios. They help you find the measure of angles when you know side length. So programmed into your calculator, right above the sin, cos, and tan buttons, are the functions that you need to be able to calculate. Now on my phone, I had to turn my phone, I use my phone for my calculator, not right now, but I usually do. I had to turn my phone sideways and then hold down the sin, cos, or tan button to get those inverse buttons. So you might try that with your phone. No matter what though, make sure your calculator is in degree mode. That's vitally important. But you can still look up angles on a table. Maybe you decided to just not even worry about the calculator thing, and you liked using those tables before when we were talking about trig ratios. Well, you still can, but you're going to be finding them backwards. Before you knew the angle, and then you found the sine, cosine, or tangent. Now you're going to know the sine, cosine, or tangent, and you're going to look up the angle. So those charts are in Google Classroom. Here's what they look like, and here's what I mean, and then you'll see it in an example. So for example, if you calculate the cosine and you get 0.98-ish, you know that that's an 11-degree angle. If you calculate the tangent and you get 1.8040, you know that's a 61-degree angle, and that's how it's going to work. You're going to end up with these numbers first, and then you'll be able to look up the angle second. That's going to be the same. This is the same table, and we will come back to these, and I'll show you what I mean as we do an example. So the steps for this is going to be very familiar. Step 1, notice what you know about a right triangle is two side lengths, and what you want to find is an angle measure. Identify the sides, opposite, hypotenuse, adjacent, just like you did before. Notice the sides that you have, and this will help you set up your equation. Pick the correct trig ratio based on what you have. Use SOHCAHTOA to help you set up the equation, and then solve. This is almost exactly like what you did before, with a slight difference. So let's try it. So notice that I have a right triangle, and what I have are two side lengths, 9 and 18, and what I want is this angle measure right here. So that's what I've done first. I just kind of looked at the situation. Now, because I have experience, I I can tell you already, the question mark is a 30-degree angle. Anybody see why? Because we have one side of a right triangle that measures 9, and a hypotenuse that is 2 times that. And that means that we've got a 30, 60, 90 triangle, but maybe you don't know that. So let's see if I'm right. Let's see if that's a 30-degree angle. So now we're going to identify the sides. Now this is familiar. Now this is where this question mark comes in, and we might just as easily call it theta because that's what we're trying to figure out. Opposite theta, just like before, is over here. The hypotenuse is over here, and the adjacent is over here. So labeling the sides is exactly the same. So then let's notice the sides that we have. Before we did like what we had and what we wanted. Now we notice that we have the opposite side, and we also have the hypotenuse, and this is going to help us pick the trig ratio. So then pick the correct trig ratio based on what you have. Well, there's still like sine, cosine, and tangent, just like before. We still remember them with SOH, COS, TOA. And now we're going to pick the right one. Now, we have information about the opposites, the O, and we have information about the hypotenuse, H. So we're going to pick the trig ratio with the O and the H, and that's the sign. These aren't going to be useful. And then we set it up exactly the same way as we did before. We're going to use SO to help us set up an equation. So now it's going to look slightly different. We're going to say the sine of the angle is the opposite, which is 9, over the hypotenuse, which is 18. So we still use the same sentence, the sine of the angle is the opposite over the hypotenuse, but now it looks a little different because the variable is in a different place. Before, the variable was a part of the fraction on the right. Now it's standing in for the angle because that's what you're trying to find. Okay, so we did that. And now we're going to solve using our calculator in degree mode or look it up in the table. So here's how we do this. So first of all, start here. And just plug that into a calculator because we're going to be working with decimals. It's how everything's kind of set up for trigonometry. So sine of the angle, or theta, is, and what is 9 divided by 18? It's 0.5. Okay? Now, let's go back to the trig tables. You notice right here, under sine, we can find 0.5. What angle has a sine of 0.5? A 30-degree angle does. And that is done. Then we would know that the sine is 30, or rather the angle is 30 degrees, because we can look it up. Tables are nice for that purpose. We can also kind of use a inverse function to cancel the sine. Let me tell you what I mean. So in any other algebraic equation, you'd want to get rid of this part. Well, you can, but you sort of eventually multiply each side by what's called the sine inverse. And that's why your buttons look like that. Because what you're doing is multiplying, and I'm putting that in air quotes because you're not really multiplying, you are applying an inverse operation, and what that does is it cancels this side. And so all that's left on that side is theta, which is exactly why you did it. And now on this side, you have the sine inverse, and we put it in parentheses so it's just more visible, of 0.5, and that's what you're going to put into your calculator. So in my calculator, I have to do second, hold on, I have to put in 0.5, and then second sin, and that gives me 30. We know it's a 30-degree angle because that's how 30, 60, 90 triangles work, but also we looked it up in the trig table, but we can also plug it into a calculator using the inverse sine button that's above your sine key. All right, shall we do another one? part is wrapping your head around that new button, but once you do, you're good. Everything else is pretty much the same. So let's notice what we have here. We've got a right triangle. We have two sides of that right triangle, and we want an angle. And so we have done our noticing. Now let's identify our sides. Theta is way over here, and all the way on this side is our opposite. Over here is our hypotenuse, leaving this side to be the adjacent. So we've identified the side. Now we're going to notice what we have. So we have the opposite, and we also have the adjacent, and this is going to help us pick the correct trig ratio. There's still three, the sine, cosine, and the tangent. We have SO, CA, and TOA to remember them. And we have the opposite, and we have the adjacent. And so we're going to use the tangent this time, and those two are useful. So now we're going to use tangent to set up our equation. The tangent, actually, I'm going to move that down a little bit to give myself a little more room. The tangent of the angle is the opposite, which is 27, over the adjacent, which is 52. And now we just need to solve, because we set up our equation, and we're about to solve. Now, let's start with that fraction and say that the tan of the angle is 27 divided by 52, boom, 0.519, so about 0.52. Now we could go and find 0.5192 in the trig table and look up the angle, or we can get used to the idea that in order to get rid of this tan part, this is what we want to get rid of, we can apply the inverse function. In other words, we're not really multiplying, but it helps us remember that we're going to apply that inverse tan on that side, which causes this cancellation here, leaving theta by itself. But remember, we have to do the same thing to both sides, so we're going to do it over here too, and we have the tan inverse of 0.52, and that's what we're going to plug into our calculator. So I have to do 0.52, and then the second button, and then tan to get the tan inverse, and I get 27.47 degrees. Theta is 27.47 degrees. Done. Now I know the measure of that angle. The steps are mostly the same, and you use your calculator slightly differently, but almost everything is exactly like what we were doing when we were doing trig ratios. All right, we'll do one more. Okay? First step, notice we have two sides of the right triangle, and we want an angle. So we're going to use inverse trig function. The next thing to do is to label those sides. Well, across from theta is the opposite. Across from the 90 degree is the hypotenuse, and the adjacent is the other side. We have the adjacent, we have the hypotenuse, and that's going to help us pick the right trig ratio. There's sine, cosine, and tangent, remembered by so, so. All right, so we have an adjacent, we have a hypotenuse. It looks like we're going to use the cosine this time. The cosine of the angle is the adjacent over the hypotenuse. So let's start simplifying. The cosine of the angle is 13 divided by 25, which is 0.52. Now at this point, we could look up 0.52 in the cosine column of the table, or we could apply inverse function. We could say that the cosine inverse of cosine theta equals the cosine inverse of 0.52. And that's real handy because these cancel, leaving us with the angle measure equals the cos inverse of 0.52. So I'm going to plug in 0.52 and then second cos, and I get 58.67. So the angle is 58.67 degrees. And we're done. The process is very much like using trig to find side length, It's just that you're using the inverse function to take side lengths and turn it into angle measures. And that, my friends, is inverse trig. Your practice is again on quizzes. If you have any questions, please do let me know. Have a wonderful day. Bye.